Math is a wonderful thing. Math is a really cool thing.
Alright, so let's try to summarize what we have learned so far. So first, we learned how to find the domain and the range given a graph. Either we have a discrete graph or a continuous graph. We also learned how to find the domain of a function or range of a function given that the domain is being restricted to certain values. And then now we are going to discuss how to find the domain and range if either domain or range is being restricted. So let's have our first example. So here we're trying to find the domain of the function f of x equals 1 plus 8x. But the range is being restricted to y greater than or equal to 17. So the shortcut here is to solve for your function depending on what is being restricted. So our range is being restricted. So we know that we have y greater than or equal to 17. It means that in our function y equals 1 plus 8x, we have to isolate our y. So if the range is being restricted, we have to solve for y. But since y has been solved already, we don't need to do that. Now I'm going to use my symmetric property. I'm going to write my y to the other side of the equation. 1 plus 8x equals y. And then I'm going to bring down our range y greater than or equal to 17. Now why did I use the symmetric property? I wanted you to see the connection between the function and our range, the given range. Remember that we're trying to find our domain. So I have here 1 plus 8x equals y, but y is greater than or equal to 17. So we can use our transitive property and say 1 plus 8x is equal to y, but y is greater than or equal to 17. So we can say then that if this is equal to y and y is greater than or equal to 17, I can say that 1 plus 8x is greater than or equal to 17. From here, we can solve our x, and that will be our domain. Solving for x, subtract 1 to both sides. 8x greater than or equal to 16 divided by 8. We'll have x greater than or equal to 2. So the domain of the function f of x equals 1 plus 8x, if the range is greater than or equal to 17, is x greater than or equal to 2. Alright, second example. What is the range of the function f of x equals 14 minus 3x if the domain is restricted to less than or equal to 11? So our domain is being restricted. So from our given function, which is y equals 14 minus 3x, I am going to solve for x. So earlier, y was being restricted, so we solve for y. Here, domain was restricted to x less than or equal to 11. So from our function, we have to solve for x. So how do we solve for x? I will subtract 14 to both sides. So my plan here is to isolate my x. I want my x to be on the right side. Just like what I did earlier, I want my y on the right side, and then I connected the given range. So here I will isolate my x, and my plan is to let x stay on the right side. So y minus 14 equal to negative 3x divided by negative 3. So we'll have y minus 14 divided by negative 3 equal to x. My domain is less than or equal to 11. Now I hope you understand now why I want my x to be on the right side. It will be easier for us to see the connection between y minus 14 divided by negative 3 and the less than or equal to 11. So here we know that y minus 14 over negative 3 is equal to x, but x is less than or equal to 11. We can say then that y minus 14, which is equal to x, is less than or equal to 11. I just need to solve for my y, and that will be the range of the function. Solving for y, my first step here is to multiply both sides by negative 3. Since I multiplied by negative 3, I have to flip the inequality. Negative 3 and negative 3 here will cancel out. Y minus 14. 11 times negative 3 is negative 33. Add 14 to both sides. We'll get y greater than or equal to negative 19. So this will be our range for this function given that the domain is less than or equal to 11. So let's try to summarize. I have the function and the range was given. So you need to solve for y here. And then we want the y to be on the right side so that we can connect the function and our range. Just solve for x and that will be your domain. Here, the given was your domain. So solve x from your function. That's what we did here. And then connect the x here to the given domain. So we know that y minus 14 over negative 3 equal x, but x is less than or equal to 11. So we can use our transitive property and say that y minus 14 over negative 3 is actually less than or equal to 11. Solve for y and that will be your answer. Okay, another example. I have here a function and the range is given. So this will be your hint. Since the range is given, we need to solve for y. So I have here y equals negative 2x minus 7. We don't need to solve for y because y is already been isolated. What I need to do here is to use transitive property and then just bring down the given range. So from here we can connect negative 2x minus 7 and greater than or equal to 9. So negative 2x minus 7 is equal to y, but y is greater than or equal to 9. So I can say that this y, negative 2x minus 7, should be greater than or equal to 9. So from here, we just need to solve for x, and that will be our domain. So add 7 to both sides. Negative 2x greater than or equal to 16. Divide by negative 2. Cancel out negative 2 and negative 2 using our multiplicative inverse. We'll have to flip the inequality. 16 divided by negative 2 is equal to negative 8. So this will be our domain. Okay, next question. Note that here, given the function 2x plus 4, the domain is being restricted from x less than or equal to 16. So this is your hint. You need to solve for x. So I have here y equals 2x plus 4. Let's solve for x. Now I want my x to stay on this side, right side of the equation, so that I'll be able to connect this with our domain, which is less than or equal to 16. Solving for x, I need to subtract 4 to both sides. We'll have y minus 4 equals 2x. Divide by 2, we'll get y minus 4 over 2 equals x. But x is less than or equal to 16. Now, this is equal to y. This is equal to x. And x is less than or equal to 16. Just solve for y, and that will be the range of the function. So I will multiply 2 to both sides. So this is your multiplication property. Then use your multiplicative inverse to cancel the denominator and the number 2 here. We'll have y minus 4 less than or equal to 16 times 2 is 32. Add 4 to both sides. We'll have y less than or equal to 36. So this will be the range of this function if your domain will be restricted to less than or equal to 16. What is the range of the function f of x equals to x plus 4 if the domain is x greater than or equal to negative 2, or if the domain is greater than or equal to 0. So since our domain is being restricted, we need to solve for x from this given function. We have y equals 2x plus 4. Let's solve for x. Minus 4 to both sides. Y minus 4 equals 2x. Divide by 2, we'll get y minus 4 over 2 equals x. But our x here is greater than or equal to negative 2. Using our transitive property, y minus 4 over 2 is equal to x, but x is greater than or equal to negative 2. So we can say that this x is greater than or equal to negative 2. Solving for y, multiply both sides by 2. This is our multiplication property. Once you cancel your denominator, that's our multiplicative inverse. Negative 2 times 2 is negative 4. Add 4 to both sides, we'll get y greater than or equal to 0. So if your domain is greater than or equal to negative 2, the range of this function is greater than or equal to 0. Now what if your domain is greater than or equal to 0? So you'll do the same thing. Solve for x here, just like what we did here, which is y minus 4 over 2 equals x. Now since x here is greater than or equal to 0, using our transitive property, we can say that your y minus 4 over 2 is greater than or equal to 0. Solving for y, use our multiplication property, multiply both sides by 2. Next, use our multiplicative inverse, cancel this one out, y minus 4, and then 0 product property. No, this is the multiplicative property of 0. So any number multiplied to 0 will be equal to 0. Add 4 to both sides. So your range here will be y greater than or equal to 4. Okay, so that will sum up our Unit 3, Functions and Relations. So I hope that you enjoyed this unit.
Okay, can I just say something crazy?
I love crazy.
Math is a wonderful thing. Math is a really